Today I wanted to tell you about a project that I started almost exactly a year ago. So the way I structure this talk is more of like a 30-minute thing. So it can be more of a conversation if you have to ask questions in the middle of it. So I structured it to be for 30 minutes because the project is so in its early stages, it's more helpful for me to get feedback from the community, especially since there are so many of you who work on projects that I try to analyze for my project. So if you have any questions, concerns, or if you want to collaborate, or if you want to volunteer to analyze projects that I'll tell you a little bit about today, like let me know. Oh great, now this is not working.
If you click on the screen and try to use it.
Oh, it's working. Yeah. All right. So the story kind of starts with a little bit of background for how my professional career led to this. As Pete just introduced me, I started as an astronomy instrumentalist in the Columbia Physics Department. And then I did the Physicists Coalition Fellowship, which got me started thinking about nuclear security issues and how physics can actually impact the rest of society, and how projects within academia specifically can lead to nuclear proliferation later on. So I ended up doing a postdoc at Stanford. It was a very short postdoc because it was not a pure physics postdoc. So this project is in its inception. But when I was not, during my PhD, when I was not at the MGM Observatory in Arizona, looking at the night sky and trying to think of anomalous gas and nearby galaxies and nebulae, I was in Pupin Hall, which is the home of the physics department at Columbia. When you walk into Pupin Hall and you look to your left, the first thing that you see these days is a row of scientists, mostly men, and what you see right next to their faces is what their contribution to science was. What you cannot see anywhere in the building is what the consequences of their science actually had on the community. So in certain aspects, it could almost be a roll call for the Manhattan Project. Most of the scientists contributed to the Manhattan Project and to the deployment of the first nuclear bomb that was ever used, and the only bomb that was ever used in the history of humanity. You cannot even find a mention of how even the football team at Columbia used to carry radioactive material with their bare hands into the 7th floor of Pupin, where they now house all of the graduate students. So, yay. When I was starting to think about this project, I looked through the archive of the Columbia Spectator, and I found this quote by Salvadori, who was a physicist who was working with Fermi on the Manhattan Project at Columbia. And he said, I asked Fermi once, how do you feel? And he said, I was put on this earth in order to make certain discoveries. What people or politicians do with them is something I don't care and I don't worry about. So the reason behind starting this project was really to get physicists to think more about the consequences of their science to the broader community. Not just physicists, scientists in general, but mostly physicists because of my own education background. So the way I structured this talk is to tell you a little bit about the motivation behind this project that was started a few months ago, the questions that I'm trying to answer with them, and then touch a little bit on the projects that I'm trying to analyze to try to identify dual purpose research in projects pursued specifically within academia. I also expected that there might have been a few political scientists in the audience. So if it's too little physics for you during my talk, you can come talk to me afterwards and I can give you more of the details in gory detail about the projects that we're analyzing. So in terms of extra motivation for this project, when we think about the non-proliferation regime, which I'm defining right here as the treaties that kind of set the tone for how nuclear science and nuclear research is used in different countries and how nuclear weapons are regulated in different countries. And then you have the agencies that kind of oversee these treaties that verify and inspect nuclear facilities in different countries and whether they are complying with those treaties. But when you think about this non-proliferation regime, they have very good ways to identify budding nuclear weapons programs in different countries from a classical point of view, but they don't have a good framework to analyze contemporary research, things that are being funded right now in the last 2 to 5 years, and how they're going to impact nuclear proliferation in the future. And when we think about scientists themselves and funding agencies that sometimes do not want to take part in nuclear weapons production, they also don't have a good sense of what is going to be dangerous in the future and what is not going to be dangerous in the future. And how can we put systems in place to make sure that this is not going to impact society more broadly in a negative way. So that was the first motivation to do that. And then when we think about nuclear weapons right now, the ones that are currently deployed by Russia and the US are about 5 times more powerful than the ones that were dropped on Hiroshima and Nagasaki. And despite the fact that bombs are a lot more developed now and are not a lot more dangerous now than they were in the past, there are physicists who are still working in facilities to make these bombs even more powerful. And even historically, we've had even more powerful bombs deployed. Luckily, they're not deployed anymore, but they're not fully disassembled. So we want to make sure that this trend that we had in the past is not going to be the future of nuclear weapons or the future of warfighting in the world. Another thing that you might think of is that nuclear weapons production doesn't only impact people based on whether they're going to be deployed or dropped somewhere. They also impact people based on plutonium pit production that has a huge impact on the local communities that end up having generations that develop cancer because of that, because of contamination of soil, air, and water. And there's some work that the Physicists Coalition have been doing, if you ever want to read work that they have been doing to advocate for systems to be in place to control that. I'm happy to share these articles with you. And this is also another great article that is not by the Physicists Coalition, but talking about how plutonium pit production can also impact local communities. So there's a whole nuclear weapons complex, not just that impacts their communities, that is not just related to whether or not a bomb is going to be dropped. And then when we think about frameworks that already exist to try to analyze academic research that impacts, that has some relationship with the nuclear weapons complex, one of the first reports that came out was the 2019 report by the International Campaign to Abolish Nuclear Weapons, which is called Schools of Mass Destruction. Yale is luckily not one of them, but Stanford was. So talking about this in my previous job was actually a little contentious. And so this universities that they identified, the 49 universities, had academic roles, or like their academic labs have roles in direct management of the stockpile, institutional partnerships with nuclear weapons labs, research programs that kind of were related to the nuclear weapons research that took place in the labs, but also workforce development. So sometimes they are not even developing nuclear weapons, but they're building the pipeline to those nuclear weapons labs and people who are going to be building the future nuclear weapons. Another framework that already exists also is a report by the Carnegie Endowment called Towards a Nuclear Firewall. It was released in 2017. And it's a very good report, but it looks for classic signs of nuclear weaponization. So they look for, and they analyze the history or the research in different countries to try to identify reactor operations, whether this country has controlled the fuel cycle of the nuclear fuel cycle, if they have delivery systems and military structures in place to deliver nuclear weapons. But throughout their entire report, they never mention research that is being funded right now that is not within the nuclear weapons complex, defined as the nuclear weapons labs for those countries. And that got me thinking, like, what can we do to have to be more proactive to communicate to the scientific community that their research might be impactful to nuclear proliferation in the future? So how can we identify early on that a project might be leading to nuclear proliferation, not just now, but 10, 20 years down the road. And that I'm looking at projects that are very recent, that have been funded or is starting to get published like 2 to 5 years ago. For the sake of this talk, there are 2 ways in which I'm going to be defining dual purpose. So one of them is defining nuclear or civilian research in academia. So what you're all are taking part in versus research that is done in the military. There are multiple ways in which people define dual purpose. For another project that I was pursuing when I was a postdoc, because I was working on 2 separate projects, it was thinking about nuclear research versus nuclear weapon research in the military, because some countries that don't have nuclear weapons also have nuclear research that is hard to inspect because of the settings in which they take place. But most of what I'm going to be talking about today refers to civilian versus military research, like research that is done in universities, but that can aid the military. But when you read about dual purpose research in other media, it's good to try to look at what kind of definition they're using, because multiple people use different definitions for it. So there were 2 projects that I had started working about a year ago. The one that I'll focus most of my time or all of my time on today is just projects that were funded by the National Nuclear Security Administration and within universities, and how we can identify the purpose within them. But I have worked a little bit on how to inspect and verify projects in the military, such as the Brazilian nuclear power submarine, which is in a non-nuclear weapon state. So if you have questions about that, I'm also happy to answer that later. For the study that I was working on during my postdoc, the one that took most of my time, I was analyzing the Stewardship Science Academic Alliances Program sponsored by the NNSA, the National Nuclear Security Administration. So in 2022 specifically, they funded 36 different projects. And one of the reasons why I chose 2022 is because, one, they made their list publicly available. And every time you try to reach them to ask for projects in other years, or even in 2022, they're very secretive about it, even though it's a publicly funded project that is not classified, or a program that is not classified. And you have access to all 36 projects online, and the list of their names, the labs where they're being pursued. And the other thing that is helpful about this is that since it's 2022 and I started this project in 2023, we're finally starting to see results. And then in 2024 is when we finally got access to more information about this project and started to fully analyze this project. One thing about the NNSA is that they are the organization within the Department of Energy that oversees the nuclear weapons stockpile in the US. So both management and development. And so when you look at the list of projects that they are funding, it's usually because they have some interest related to nuclear weapons. They are funding those projects because there is something related to nuclear weapons there, even if the project is not fully saying we want to develop nuclear weapons for this specific project that we're seeking funding for. But that can go both ways. It could also be management or remediation. They have projects on inspection and verification as well. But that list kind of gives you a hint in what kinds of projects are people funding right now for the development of nuclear weapons, or like to develop science that is going to enable the development of nuclear weapons in the future. So what the project that I started last year intends to do is to make a framework that scientists can use to evaluate the risks of their own research, so they can choose whether they want to pursue that or not, so they can make informed decisions. Enable funders, sometimes NSF and NASA, for example, or private funders do not want to be involved in nuclear weapons development, but they do not have a full understanding of what is nuclear weapons related research and what is not. So enable funders to make those informed decisions as well. and enabled the non-proliferation regime to spot like budding projects in different countries, not necessarily in the US, but have the framework that can be applied to other things later on. What this project does not intend to do is make judgment calls on what different government agencies should fund. The NSA, the military, governments across the globe, not just in the US. I'm not trying to determine what research projects should not be pursued, because like they're dual purpose. Clearly, they have a purpose that is not nuclear weapons related. I'm not trying to determine whether it's ethical or not to pursue a specific project. And I'm not creating an all-encompassing framework of everything that will ever be weaponizable in the future. That would be extremely hard and not worth my time. So the way these projects are evaluated for the 2022 project specifically, we had to switch our methodologies completely because in March, the NNSA made all of the slides from all of the projects available for every single project that they funded. And that kind of gave you, and I'll give you examples of projects that we're evaluating and what kinds of information we can extract from those slides. And I don't know if they made them available on purpose or not, but I'll just state it. But we get materials from the projects that were funded by the NNSA in 2022 from the Academic Alliances program specifically, because the NNSA also has programs in national labs, and those are not things that I'm looking at. Then we go for a reading group or an expert survey. So some people like how they volunteer to analyze projects. And what we do there is identifying weaponizable features of this project. And the way that we do that is by registering the data in a questionnaire. So the questionnaire is kind of a triage for this project. So experts in specific fields can pick one or two projects that is very closely related to the research that they do. So they can answer questions like, what is this project about? How do you see the pace of this project going? So from the pace of this project, how far in the future do you think that this is going to be applicable to nuclear weapons development? How is it going to be related to nuclear weapons development? What kind of calculations and simulations might be helpful for us to conduct in order to be able to analyze this project and its feasibility for nuclear weapons use? And so there's a series of questions that these people are answering, and then we get multiple people to analyze every single project, and then we kind of take that as our basis to be able to make a framework later on and this framework, I'm hoping that it's going to come out in the form of a public report that people can easily reference to. So the group right now includes members from Stanford, or scientists from Stanford, Yale, Columbia, Princeton, Illinois State, San Jose State, and Cornell. And those are people who are not just physicists. Sometimes they're geoscientists, engineers, mathematicians. So if anyone wants to volunteer to read a slide or two and answer some questions about projects, feel free to let me know. Some examples of materials that we get when we look at those slides. We get sometimes descriptions of projects in excruciating detail of what these projects are pursuing. Sometimes we get what kinds of methodology and what kinds of instruments, what their experiment setup looks like. Lots of them have preliminary results with which we can kind of determine the pace of the project, or in the last 2 years, what has this project accomplished? And some of them have already published some results. Sometimes PIs try to say that they publish all of these papers on that specific project, when in reality, only one of them is related to that specific project. So we have to be very careful. Is like reading the papers and figuring out whether it's actually related to that project that was funded. But having those links is extremely helpful for us to have extra information beyond just slides that sometimes don't have descriptions on them. Sometimes they have speaker notes on them as well. I don't think the NNSA was trying to release them, they did. So those explain some of the data and preliminary results as well. So when I say very preliminary findings for what I found here is because we're still trying to get at least 2 people to analyze each project. Those are things that I came up with on my own, and I'm not an expert on every single physical science field that I read a project on. But in general, about 17 of this projects, of the 36 projects are in physics departments, not surprisingly. All of the PIs in other projects have some training in physics or in very, very closely related fields. So having physicists involved in this kinds of, in making this kinds of frameworks is actually extremely helpful. But among the 17 projects, 2 are in astrophysics and completely inconspicuous. Like you would look at them like it's a regular astrophysics project. 4 are in condensed matter, and 1 is in plasma physics, which is sometimes a little more related to nuclear weapons production, but it still can fly under the radar. All other projects are in closely related fields to physics. 13 of those projects that I personally deemed and like had some input from other people, but we're still trying to collect all of the data. 13 of those projects are not on ICANN's report and the Schools of Mass Destruction report. So it goes to show that other institutions are also contributing to nuclear weapons development. Maybe not that they want to do that, but they might be contributing to it. And at a first glance, 23 of the 36 projects have some weaponization risk, but only 1 of them mentions weapons in the materials that they published or that they made available publicly. This one project is a project that in their proposal and in their slides explicitly mentioned the weapons complex. The other projects don't even mention warheads or plutonium pits or anything in that regard, or among the ones that are potentially weaponizable. And the way I understood this project is that they were trying to characterize microstructures in different materials to see if they were applicable, or to see how strong those microstructures made the material. But when you look at the papers that they actually publish publicly, they never mention weapons. They generally mention the auto industry and that this is how their project is actually applicable more broadly. So that gives us a kind of a clue of like, if we're looking, say, we're not looking for projects in the US, we're trying to evaluate projects that other funding agencies are funding in other countries in which we're concerned about nuclear proliferation because they're non-nuclear weapon states right now. They might become nuclear weapon states at some point. Maybe we should be looking for things that people are publishing to build cars as opposed to build weapons. Getting the specific language around those projects that we identify in this framework is useful to project onto other countries that we're trying to evaluate projects from. Other not so obvious dual purpose research, and again, I'm not saying that they are trying to build weapons, but that the NNSA is interested in because of their role in weapons research. Is this one right here. So they say that their goal is to investigate novel states, property and chemistry of low Z planetary temperature under extreme conditions. Low Z essentially in their case essentially means hydrogen and helium. Under extreme conditions, you're applying a lot of pressure to it. So really, when the NNSA was looking at it, they probably thought, oh, H bomb. But the only technology that they're spinning out of it, according to their materials, is to try to get setups in physics labs to understand high pressure, high temperature environments for the development of planetary cores. And sure, I think that's extremely interesting research. We should be able to understand how like planetary cores are developing, but we should also have things in place to try to understand how can we prevent this kind of studies from becoming nuclear weapons 10, 20 years down. If you believe that we should live in a nuclear weapon-free world, some people don't, but the other projects that are not so obvious, for example, this one, I think it's called Z to Planets. It's also planetary core kind of development. So their goal is to understand properties of the major building blocks of Earth-like and water-world planets in order to develop better models of, and they go on to things about atmospheres and planetary cores. But really, the reason why the NNSA might have been interested in thinking about how low Z materials go into become eventually it's because of fusion. So things are fusing and fusing and fusing, and like how can we develop fusion? And maybe potentially use that for a weapon. But there are also other projects that the NNSA funds that are actually very interesting and very helpful to the community. For example, this one, they were trying to mitigate the risks of plutonium pit production in their local communities by analyzing how they contaminate air, water, soil, doing field studies to try to determine how the impact of plutonium pit production around the area where they are where those pits are produced and stored. So that's also an example of dual purpose that is not necessarily for nuclear weapons or weaponization. So it's also kind of interesting to see like where do we draw the line of what is going to go into weaponization and what is not going to go into weaponization. In terms of possible future directions for this project, as I mentioned during my lunch with some of the students around here, like I'm not pursuing research full time anymore. My job is mostly administrative and teaching, but talk to me and my release time next summer, and then we'll see where this project's going. I'm pursuing this more as an advocacy project, a passion project on the side. So I would love to get the people who volunteer to analyze the projects together, to continue analyzing these projects, make a framework that turns into a public report that scientists can reference to. Maybe we can start talking to people. There are people who literally study the ethical implications of different aspects of nuclear weapon production. Maybe get those to start thinking about the ethical implications of different science projects, and maybe get the physics community to think more about that. Once we have that framework, maybe we can start thinking about what kind of safeguards and regulations might be applicable to those projects, even when they are in their earlier stages. If we can cross-reference those projects to lists of funders that are not associated with nuclear weapons production, like NSF and NASA or private funders. And one thing that I really wanted to do, and I've been partnering with someone who's at Stanford right now in my previous department, is to try to automate the process of finding this project by using large language models to get the language from the projects that we're deeming weaponizable, to try to cross-reference that to papers that are coming out from other labs, and use that large language model to see how widespread those kinds of projects really are beyond what the NNSA is currently funding. But yeah, I would love to get feedback, especially because a lot of you work on projects that might be funded by the NNSA. Again, this is no ethical judgment on my part. I think those projects are extremely interesting. But yeah, thank you.
Thank you, Barbara. Are there any questions for Barbara? Edith?
Yeah, so I have asking for clarity. So the NNSA is specifically talking about nuclear weapons, whether that is detection or making production, question mark?
They do the stockpile management. They manage the stockpile.
Okay, so
in the US.
So like, I guess the way I'm thinking about it is, when I think of DoD funding, I wouldn't touch that, because I'm assuming that is something military, something I don't want to do, right? That's at least the interaction that I have in my head between those two words. So I guess I was assuming, when I hear NNSA funding, should I immediately think nuclear weapons? I'm just curious.
I mean, that's their main goal. Their main job is to manage the nuclear weapons stockpile in the US. That said, they fund, as you can see, like a widespread range of different projects. But their main interest is either to do remediation, inspection, and verification, but also nuclear weapons development and management. Okay. So when they're funding something,
Absolutely.
Something
yeah.
related to nuclear weapons,
Okay.
and they're within the DOE. So when you look
Right.
through the funding that comes to nuclear weapons in the US, there's never like a line that says, this is how much funding nuclear weapons get, because they're all spread across the
Right.
DOE and the DoD for various different categories, and it's very hard to determine how much money nuclear weapons are actually getting.
I see, but so. I thought that maybe this is my naive, just a physicist understanding. When you get a grant, if it's from the DOE, it's public, right? And NSF grants are public. DOD grants might not be public, I'm assuming, because, and I'm thinking military.
Yeah, but if you try to contact the NNSA to try to get information.
Right, no,
No response here.
no, right, I see, so it's just, there's that, red tape.
Yeah, I mean, the DoD is, I think the DOE, I thought that the DOE also has classified information that they keep, but there might be some.
Classified research that you
Yeah.
can't know about.
Yeah,
Right.
I mean, I guess it's hard, I don't know if you can't know, but.
Yeah.
Versus the other research which is listed on their web pages.
Yeah.
Which is not classified. There's a two.
no, not every round of application, not every round of projects that they fund is actually like readily available online either.
That's weird. Yeah, I guess if it's non-classified, in my naive head, it should make very, you know what I'm saying, it should be
Yeah.
clear, you wouldn't have to jump through all this hoops.
It's not classified, it is public. I mean, we have to write a publicly available abstract that they post for everything that we're funded for.
But it's also very hard to find those.
Right.
We have a question online, Curtis.
Yes, hello, can you hear me?
Yes.
Oh, great. Hi, Barbara, good to see you. Great talk, and I just wanted to like make a comment and then also a question. But yeah, I mean, the overall comment is that this project is awesome, and like I, want to keep supporting and working with you on it, and I just think it's so important for the public and our field and science generally to get clarity on this information. So thank you for the spotlight you're putting on it. And in regard to the last question too, the NNSA, yeah, I totally agree. Its like main mission is weapons maintenance and development and construction. They do also have a non-proliferation mission that is just worth noting. That they do work on and fund. But the question I had was, you mentioned at the end this project about plutonium effects and like studying it in the environment. Is that NNSA funded?
It's one of the projects that they funded for the Academic Alliances program in 2022.
Okay, yeah, well, very interesting. Yeah, I'll follow up with you to learn more about that. I think that that's, as you know, something that is very interesting to me, like the plutonium pit. Yeah. So I guess I'm glad to see that they're funding some research along those lines. And generally, yeah, I think we need more outside study of environmental impacts and independent assessment of the consequences of these, gigantic nuclear weapons lab projects. So anyway, yeah, thanks. I'll follow up with you about it.
Great.
Yeah, Curtis actually wrote a great article about plutonium pit production in the Bulletin of Atomic Scientists, and people should check it out if you're interested in that.
So we go with Claire, and then we have a question online. So Claire, you can go first.
Yeah. So you showed early in the presentation that diagram of all those very scary mushroom clouds getting progressively bigger. And so when I looked at those, the impact of any of those is like so devastating beyond my comprehension. So when I think about what exactly like what nuclear research for the intention of like weapons application is looking to improve about those weapons, when the outcome is like pretty much like, I feel like any minor improvements you make to how the reaction happens or something are gonna have the same outcome, or the differences in those outcomes will be negligibly different. And I was wondering, is the research we're doing now, like, we need it to get there faster, or, you know, we need the precision to be better? Because like once you can target a city, which we can do, then I feel like you've accomplished your goal. Or is it mostly just like, well, we think this country has this, and therefore we need to also have that just to make sure? So is it like greed or arms race or?
Yeah, so the US has been trying to modernize their nuclear weapons arsenal for a long time, and their justification for it is that Russia, China is modernizing their arsenal, China is modernizing more. I had like this interesting discussion with someone from the DoD about how physicists shouldn't be naming in that, and he was like, well, that's a shame that he think that. But essentially, sometimes they do try to produce what they call tactical nuclear weapons. Their yield is a little smaller, or not a little, it's somewhat smaller. But what they don't take into account is that even by making nuclear weapons yield smaller, that what they mean by that is that they might be more usable, but you're still having fallout. Like I don't have to tell an audience of physicists that radiation spreads and impacts people far away from where the nuclear bomb was dropped. So there's research on both sides trying to be more precise, trying to make it smaller, and there's also like trying to make it more powerful. I don't think that they're going to deploy necessarily like a lot more powerful nuclear weapons, because the START treaty kind of prevents, or the START treaty kind of expired, but hopefully there's going to be a renewal of it. So Russia and the US generally have bilateral treaties trying to kind of control the yield of what bombs they have deployed. But it's interesting to think that, I mean, while the US and Russia might be in, or they're not in negotiations right now, but might be in negotiations at some point about like determining what the cap is for the yield, there are other nuclear weapon players in the rest of the world that might be coming up. And we don't want that kind of research to provide them the tools to make much more powerful nuclear weapons, or more precise, or even smaller nuclear weapons that are used more frequently, and that can still lead to nuclear winter. There's very interesting research about how like a nuclear war that comes from Rutgers University, about how a nuclear war between the US and Russia would essentially lead to famine all over the world and essentially extinct all of us within 2 years. Like the rest of the world. It's not just like where the weapons have been deployed. And so, I mean, the planet will be fine. I don't think that we will.
Yeah, sorry, that's funny.
Yeah, so there's funding for research in both directions, like trying to make things more precise, and you see that in places like NIF. I forget, is it in Lawrence Livermore or Sandia? Lawrence Livermore, to like make ignition like for fusion, and then so that would make a much more powerful bomb. But then there's also research towards tactical nuclear weapons, which can be equally dangerous when you think about how often people might be thinking of deploying them.
There's a question online, Steve. You can unmute.
Yeah, I worked at Los Alamos National Lab for 10 years, and I actually worked on nuclear weapons. And I pretty much agree with everything you say. The main thing is it's hard to do meaningful research in a university setting. You know, you can't work with plutonium, et cetera. And it's also a classification issue, and we don't allow classified research on university campuses. And I agree with that 100%. We just can't be allowed to have classified research on campuses. And, you know, as I say, I agree with everything you say. But one problem is everything we do at a university, every bit of science is applicable to understanding weapons better. There's just science. And the only way to ensure that there's no academic help to the weapons program is actually shut down scientific research. I don't think we're going to do that. On the other hand, as I said, not doing classified research on university campuses is an important thing. And if nothing else, I hope that gets amplified because there's a lot of push constantly to allow that again. And one other point I wanted to make too is those great big weapons that you showed pictures of. Most countries don't really want to have those anymore. Sort of 100 kiloton type ones that can be delivered by a multiple independently targeted reentry vehicle MIRVs. They're actually about 100 kilotons, and from a tactical and strategic point of view, they're actually more useful for those big weapons, which most of our energy goes into blowing the atmosphere out into space. And so I think that, and in that regard, these modern miniaturized nuclear weapons are actually quite complicated and tricky and delicate. And my job at Los Alamos, my team looked into assessing whether or not our methods of manufacturing plutonium and all that we would have a reliable weapon. Now, we all agree that we would be better off not to have nuclear weapons, but right now in the world, I would say that we're better off having them because we do have adversaries in the world. The Earth is a small place. There's competing factions wanting to control the whole thing. We see it constantly in the news with these little skirmishes. Well, after World War II, it became apparent that having nuclear weapons was much less expensive than having troops on the ground. For every soldier, there's 20 people behind them. And during World War II, the cost per year of running the war for the United States in today's dollars was $1 trillion a year. The cost of the whole Manhattan Project in today's dollars was $17 billion. So in 10 days of the war funded the entire Manhattan Project. So it was economically feasible, and that's in the end the big driver in everything we do. And we're now faced with the problem of certifying weapons when we can't do testing. And so there's a whole program of stockpile stewardship that used to be touted strongly by the lab, but we don't hear so much about it anymore. And but it's all scientific based measurements of materials so that we don't have to resume nuclear testing. And anyway, I just thought I'd throw those comments out. It was a very interesting talk, and I'm glad that you're looking into this. And welcome back to Yale. I think you're in my class. I think it was quantum mechanics some time ago, and so I say welcome back. That's all.
If I can respond to that very quickly, yeah, the weapons that are just deployed right now are 100 kilotons, but that's already 5 times more powerful than Hiroshima and Nagasaki, and those are the ones that are actively deployed across Russia and the US as well. In terms of, we're not going to try to shut down all of academic research. There's no classified research that is done in universities, but all kind of classified research kind of started with some academic trying to think about physics problems. And we're not trying to shut everything down, but I think it's helpful for physicists to be aware of what the consequences might be, so we can have like safeguards in place for that not to happen. And in terms of cost, we can talk about military costs being lower, but what is the cost of 8 billion people dying for nuclear winter if bombs, like a nuclear war starts? Because once a nuclear weapon is deployed, what is the end of a nuclear war? What kind of end to a nuclear war do you have in sight? So sure, it might be the cost might be lower financially, but the cost to society is much higher if you have nuclear weapons being deployed as opposed to troops on the ground.
Yeah, I agree with you completely, but from a political governmental standpoint, the savings is enormous. So that's a big driver to develop all this stuff.
Yeah.
Already?
So, suppose I am, well, okay, I am a physicist. Suppose I'm working on some research that
might have some military applications, and I read your public report and I'm like, oh crap. Yeah, this is like weaponized. What do you envision happens next? You know? Do I stop? I mean, I could stop, I suppose. But if I want to, if that research does have a very important second purpose, what then? First, I will hope that you're not working on this lab to contribute that research to weapons production, but research can be picked up from papers. That case is obvious, right? If I'm working in a weapons lab, I'm committed to making weapons, right? But I'm like the more interesting. Not necessarily. There are some physicists that just need a job, but you know, but
I'm aware of it. I'm aware of it, right?
yeah, I mean, like the more interesting edge cases that you were talking about, like the Astro cases, right?
Yeah.
Where I care about SARS, right?
I
can relate to that.
What do you think is the next step for that?
Be
research?
mindful. I mean, I'm not suggesting, so that's one of the things that I'm trying to get like a group of people to think about, because
Mhm.
honestly, in all honesty, I don't know what do you do with that information other than like try to control where you're publishing it, how you're publishing it, who you're making that information available to. And so, yeah, my answer is like, there's a lot to think about that.
I feel like that's the hardest.
That's
question.
the hardest question is like, how do you define what is ethical and what is not? Where do you stop? But having that kind of just having that kind of framework for you to think critically through the work that you're doing is also kind of helpful, so people can make their own decisions and how they want to proceed.
I think I saw Talia's hand first.
It's a lot of questions. It's great. Thank you so much for this, Barbara. I think I had like one follow-up thought on what Irina was bringing up, which is maybe a little tangential, and then I had a question. First of all, I think one of the reasons why this is valuable is there are so many cases of scientists working on something that turns out to be disruptive for both good and ill, and then being surprised by the extent to which that was true. And that sometimes just has to do not with being surprised that it specifically can be applied for something they consider ill, but just being surprised by how large the impact is. Like they're thinking more from the basic science side. And then, so like an example of this that I studied previously was the development of CRISPR gene editing technology, where some of the science who worked on it had a sense it could be disruptive, and some were doing basic science, and then it escalated very quickly into a major things they really hadn't like stopped and thought, and then later were concerned about some of the implications. So they're also positive ones, what they've done. But yeah, then the question of how to do the ethical questioning is so difficult. And I almost think it could be really interesting. This would be like a larger project, but like to have a later companion paper to the report with some science ethicists saying, okay, like using this kind of information from your report, what kinds of questions could scientists ask? But that would be a later thing, because I think it's really helpful to like be able to use that resource that you're providing more fully, if one had a sense of like what questions to start with when thinking through the ethics. The other thing I was wondering is, so it seems like there's kind of like at least two goals. One is the people who are working on these sorts of like edge case projects, the dual use projects, maybe not the ones funded by NSA, but maybe these people have collaborators who get grants elsewhere, but are really doing the same type of research, or maybe it's a grad student on this project who doesn't even realize they're funded by NSA, like being aware of what the implications are. And then the other application seems to be for people who aren't doing the research to be aware of what other people's research could do, like the case of things. They're funding things, yeah, and like the case of other countries. So anyway, I was just like,
Yeah, because the talk points that I hear from the US all the time is that we're the good guys and we have nuclear weapons and we're not going to deploy them, and then we have to make the weapons so the bad guys don't do this. And I was like, who's a good guy, who's a bad guy based on like the information that we're getting? Like who? Why are we characterizing some people as the good guys and some people as the bad guys when all of them really are just building weapons? And most countries in the world do not have nuclear weapons and do not have any interest in doing so. Brazil, for example, has in their constitution, in its constitution, that nuclear weapons are essentially unconstitutional and illegal. And yeah, so it's good from the perspective of other countries that feel safer without nuclear weapons, to be able to spot that very early on. So they're not about to do that either. Yeah, sorry, I interrupted you.
Oh, no, it's okay. That was really interesting. One thing I was wondering on the first case, the case of like scientists not realizing, is whether you think it could be interesting to like interview or question some of the scientists working on these projects, maybe especially like actually grad students or like people who might not be the ones applying to the NNSA for funding. I don't know, because I feel like I wonder if that would be illuminating as far as how much people are and aren't aware.
We thought about it, we just haven't been able to.
Yeah, that would be like an additional project.
Yeah, I know, from looking at the list of projects yourself, that it's a lot more work than it actually sounds like, because we're sitting for all of these projects and evaluating them with care, because we also don't want to like say like, oh, this is going to be immediately look at that and like sounding the alarm bells with no necessity for that. So,
Right.
But yeah,
Okay.
it'd be interesting to interview people if they're up for that. Yeah.
Okay, yeah.
So I had a question, thank you for this really intriguing presentation. I had a question about the access to data and what that means about who can apply this and how it can be applied. Because it seems like you're saying that one of the limitations of it is that the data you have access to is all what is made public. Is that correct? With the slides you can find that you can find online. So I'm curious, from an application perspective, we talked about like if individual students are applying this framework and learning about what their research is doing and saying, okay, how do I want to proceed? But from a policy perspective, if a government, for example, wanted to apply this and look at other countries and their proliferation, have you seen this or similar types of frameworks applied by like state or DoD or something like that, but with access to a more classified data set? Because it seems like that is a real limitation of the ability to assess these projects, is that it's all public.
So one of the things is that I'm not trying to assess classified projects. Obviously, every country has their own classified project.
Yeah.
Or especially nuclear weapons states have classified projects
Right.
to build nuclear weapons. But those are easy to spot because they are in nuclear weapons labs. So you know that they are related to nuclear weapons. So if you see that other countries have nuclear weapons labs, you know that they're building what they're building. There are frameworks that already exist to spot those very like classic signs of weaponization. And that usually involves trying to inspect and verify things that are generally classified and that other countries essentially try to not make public. So that's why I framed this project as more like I'm trying to educate the scientific community versus I'm trying to like identify a budding nuclear weapons program that is going to be immediate in the next 2-3 years. For those things, the government are not just the government, but non-proliferation agencies already have frameworks in place.
So the audience at the end of it is ultimately people, not
Yeah.
like governments.
Yes.
Okay, cool, thank you.
Though it would be nice if people from agencies that do not fund nuclear weapons would start paying attention to that as well.
Yeah.
Because they're also funding this project.
Okay, cool, thank you.
There's some more question.
Yeah, I guess often the primary and sometimes the only outcome of academic research or the only product is a trained physicist. And I'm wondering what the availability of data is on kind of career trajectories, and especially kind of how predictive funding sources are for the career trajectories of early career scientists.
It's very funny. One of my colleagues actually asked if we wanted to do later like a network science project. So just like where people start from and where they end up at, and who their PIs are for when they're graduate students or postdocs. Because sometimes their project is not necessarily one of these weaponizable projects, but they do get all of the skills to be able to work in weapons labs later. So someone had suggested that already. I was essentially pursuing this project by myself for less than a year. So it has not gone very far yet. because it's, as I said, my training is in astronomy instrumentation. It's not in nuclear security policy. So that's something that I picked up very recently. But yeah, it would be very interesting. If someone wants to volunteer to try to do that kind of network science project. I'll be very interested in collaborating with whoever wants to do that.
Have you thought of, because I know that for, in places where there's, kind of these, where they might be, I know you're focusing on non-classified research. Sometimes there are professors who can have appointments at national labs, but then there's still professors at labs, a university, sorry. I'm not sure, I can't think of anyone who is at a weaponizable lab, because I try to avoid it too, but I think that, I don't know, that one might be, end up an interesting avenue, because technically, if they were like, say, at Los Alamos, and they're part of the University of New Mexico, sorry, they have students that they can take to the lab, but I'm not sure how the funding then goes to like, what projects they can go to if they are working on a weapon project.
I mean, a lot of these projects are funded through multiple streams, right?
This is true.
So looking at the streams of funding that are coming to those projects is also interesting. But one thing to note is that when I was going through the list also, so the ICANN report, the Schools of Mass Destruction report, actually lists pretty clearly which schools have professors directly working in their weapons labs. But then there are still like about 13 of those projects have no one. So we can tell which schools already have that just from looking at the ICANN report, honestly. And then you can just see which departments they listed in the ICANN report and which departments those projects are coming from.
Yeah, I didn't know that. I did not know that.
But there are several that are not related to those labs. But yeah, there about half of them are. So
maybe I misunderstood it. Great thought, by the way. Thanks, Barbara. What you said, because I thought a really interesting side one would be to take these projects that are funded and try and figure out, as you said, what is being published that is seemingly non-weapons related, but would hint to agencies, the rest of the world, that somebody who signed the non-proliferation treaty is sort of starting along those ones, because everything can be weaponizable. I mean, my research definitely could be. I mean, I think every scientist could be, but as you said, there's some that's more clearly, if you know what to look for, obvious in the next few years level. But you said everybody knows what those are. I thought that maybe I misunderstood what you said. I mean, weapons research in weapons labs, sure, right? But
not so. There are projects that are in schools that are not related to the weapons complex at all, but they still put out research that is completely different, like the astrophysics and condensed matter projects. And sometimes they have they can clearly be weaponized in the future. I'm not saying immediate future, like down the road. But yeah, I completely agree that like one of the main applications is just being able, so that's why I wanted to do the large language model like a large language model to try to sit through papers that are coming out from different countries and different universities, different labs. So like you can categorize that and see which ones are actually, because you can see the language that is being used in those projects that are clearly weaponizable, and then try to see if that same language shows up elsewhere. But it's one of the things that we're trying to do. But there's a friend of mine at Stanford who literally works on just like working on machine learning and large language models, and then I was talking with him, so we could like try to bring that to fruition at some point.
One last question, Ricard.
So one thing that it's always confusing. So most of the nuclear weapons or nuclear reactors, wherever, they have turned into more engineering, right? I mean, it's not nuclear physics anymore. Physics is established decades back. And now it's most of the developments we are talking about are technological rather than basic science. Now, if you go in that direction, then anything you name, AI, machine learning, computer softwares, material science, light material, you name any technological development, they all can directly in all the weapons and so. So what I'm trying to understand is why there is so much emphasis on the academic institutions, which are actually doing less as compared to the technological labs or like R&D labs or like companies. So what's the?
I think the main reason is to try to raise awareness among scientists, because people usually say I'm doing science for the sake of science and I'm not like caring about the consequences of it. I'm kind of like for reset once. But the other thing is that that's why part of the project is also trying to establish a timeline for in which those kinds of projects might be actually weaponizable, as opposed to just saying like, this is weaponized, this weaponized, this weaponized. It's like, what is the degree of risk that a given project imposes? And sure, a lot of those projects are engineering projects, but there's a lot of things that scientists, like pure scientists do, like condensed matter research or like planetary core research that plays a role in modernization of nuclear weapons, not just like, but sure that we know how nuclear weapons built, but what is going to be used next in modernization efforts? Like the US is trying to put a lot of money into modernization. Like the modernization attempt that they had very recently got shut down, but who knows, like depending on who the next president is, how much money is going to be placed into modernizing those nuclear weapons or delivery vehicles as well. It's not just the actual weapons. Delivery vehicles can change all the time. And so
yeah, I guess what I was trying to say is that people should be aware of what they are doing, absolutely no question about it. But is there like some way to sort of also educate maybe like the private sector people like who are working in like companies or like manufacturing? Because there are people in private sector who don't want to work on nuclear weapons, but they don't know what their companies do, right?
yeah,
And they're more blindsided there as compared to academic institutions, that I feel sometimes. Because
I feel like private sector folks are already like working as contractors for those nuclear weapons labs, so they know what they're doing. The scientists are more unaware that what they're doing might actually have implications. So that's my counterpoint to it, I guess.
Is it also that, I mean, we're publicly funded, right? So there's an element of responsibility there that's different from the private sector, right?
Yeah.
They're making money and funding themselves, right? Whereas we get taxpayer.
There's also that.
Also might just be like the things to look for, the sort of hints might be different in the two cases. And so they're just like, can't do everything at once, right? And they're both worth looking at.
Yeah, and also just if you're gonna try to narrow the scope for an actual research project to work, like going to every single like defense contractor out there is not gonna be feasible, but looking at things that scientists are doing, so we can try to educate at least that population. I think that also kind of stems from my interest in these kinds of issues, which stem from my participation in the Physicists Coalition, which is trying to educate physicists and people who are in universities who are completely unaware of these issues. So, of course, like people's biases also play a role in their research. We cannot deny that.